On the Moon Volume 103. Welcome to this episode of On the Moon. I'll be your host today and we're talking about Firefly Aerospace's Blue Ghost Mission 1, a historic leap in commercial lunar exploration. On March 2, 2025, Firefly Aerospace achieved a monumental milestone in space exploration with the successful soft landing of its Blue Ghost Mission 1 lunar lander on the Moon's Mare Crisium. This historic event marked the first fully successful commercial moon landing, positioning Firefly as a trailblazer in the burgeoning lunar economy and a key player in NASA's Commercial Lunar Payload Services (CLPS) initiative. Named Ghostriders in the Sky, the mission not only demonstrated Firefly's technical prowess but also advanced scientific understanding of the lunar environment, paving the way for future human exploration under NASA's Artemis program. This article explores the mission's objectives, technical achievements, scientific contributions, and its broader implications for commercial space exploration. The mission, a journey to Mare Crisium. Firefly Aerospace's Blue Ghost Mission 1 launched on January 15, 2025, at 1:11 a.m. Eastern Standard Time from Kennedy Space Center's Launch Complex 39A aboard a SpaceX Falcon 9 Block 5 rocket. The mission, carrying 10 NASA science and technology payloads, embarked on a 60-day journey that included 25 days in Earth orbit, 4 days in lunar transit, and 16 days in lunar orbit before executing a flawless landing near Mons La Trail, a volcanic feature in the Mare Crisium Basin. This 340-mile-wide lunar basin, located on the Moon's near side, was chosen for its relatively flat terrain and minimal magnetic anomalies, which ensured accurate payload measurements. Sabido with 13. The Blue Ghost lander, named after the Phassis reticulata firefly species, stands 6.6 feet tall and 11.5 feet wide, designed for stability with a low center of mass, shock-absorbing landing legs, and a robust communication system featuring 1 X-band and 3 S-band antennas. Its main engine, delivering over 1,000 newtons of thrust, facilitated lunar orbit insertion and a critical braking burn during descent, while 8 Spectre reaction control thrusters slowed the lander to a gentle 1 meter per second for touchdown. The lander's 3 solar panels, generating up to 400 watts, powered its operations, which extended through 346 hours of lunar daylight and an additional 5 hours into the lunar night, marking the longest commercial lunar surface operations to date. A fully successful commercial landing. Unlike previous commercial lunar attempts, such as Intuitive Machines' IM-1 mission in February 2024, which landed at a 30-degree tilt, Blue Ghost achieved an upright, stable configuration upon landing at 3:34 a.m. Eastern Standard Time on March 2, 2025. This precision landing, confirmed by 3 of the 4 landing leg footpad sensors, was celebrated as a giant leap in commercial exploration by Firefly's CEO, Jason Kim. The mission's success was attributed to rigorous testing, innovative design, and lessons learned from prior lunar missions. Firefly's team analyzed past landings, opting for its short and squatty lander designed to enhance stability on the Moon's challenging terrain, which is riddled with craters and volcanic features. The landing process itself was a technical marvel. After entering lunar orbit on February 13, Blue Ghost executed a descent orbit insertion (DOI) burn on the Moon's far side, followed by a 9-minute powered descent initiation (PDI) burn. Autonomous landing software, supported by cameras and sensors, performed 2 hazard avoidance maneuvers to navigate boulders and rocks, ensuring a safe touchdown. The first image transmitted back to Firefly's mission control in Cedar Park, Texas, showed the lander's shadow on the lunar surface, with Earth and the Mons La Trail feature visible in the background, confirming the mission's success. Scientific contributions and payloads. Blue Ghost Mission 1 carried 10 NASA instruments designed to advance scientific and technological knowledge for future lunar exploration. These payloads, collectively weighing 94 kilograms, included experiments to study lunar regolith, geophysical characteristics, and space weather interactions. Key instruments included Lunar PlanetVac. Developed by Honeybee Robotics, this instrument used pressurized nitrogen gas to collect, transfer, and sort lunar soil, demonstrating a low-cost, low-mass solution for robotic sample collection. Stereo cameras for lunar plume surface studies, SCALPS, 1.1, managed by NASA's Langley and Marshall Spaceflight Centers, SCALPS captured over 3,000 images of the lander's engine plumes interacting with lunar regolith during descent. These images, taken at 8 frames per second, provide critical data on plume surface interactions, informing the design of future landers to mitigate dust erosion. Lunar GNSS Receiver Experiment, LUGRE. This payload achieved a historic first by acquiring and tracking GNSS signals, such as GPS and Galileo, from the lunar surface, 362,102 kilometers from Earth. This success suggests GNSS could complement navigation for future Artemis missions and potentially Mars exploration. Regolith Adherence Characterization, RAC. This experiment studied how lunar regolith adheres to various materials, aiding in the development of dust-resistant spacecraft, spacesuits, and habitats. Electrodynamic Dust Shield, EDS. Using electrical forces, EDS successfully removed lunar dust from surfaces, offering a promising solution for dust mitigation in future missions. Radiation-tolerant computer, this system operated through Earth's Van Allen belts and on the lunar surface, verifying solutions to protect electronics from radiation, enhancing the safety and cost-effectiveness of future missions. Additional payloads included a lunar retroreflector for precise Earth-Moon distance measurements, thermal exploration probes, and instruments to study the lunar interior's heat flow and crustal electric and magnetic fields. The lander transmitted 119 gigabytes of data, including 51 gigabytes of science and technology data, providing a wealth of information for ongoing analysis. Capturing cosmic phenomena. Blue Ghost's mission was not only scientifically significant but also visually spectacular. On March 14, 2025, the lander captured a total solar eclipse from the lunar surface, marking the first time a commercial spacecraft actively observed such an event. Images showed the diamond ring effect as the sun emerged from behind Earth, casting a shadow across Mare Crisium. Additionally, the lander documented a lunar sunset on March 16, capturing a horizon glow and potential dust levitation, phenomena first noted by Apollo 17 astronauts. These images, stitched together into high-definition videos, offer insights into lunar dust behavior and solar interactions, critical for planning long-term lunar operations. Lessons learned and future implications. The mission provided valuable lessons for future lunar endeavors. One unexpected finding was the thermal impact of sunlight reflecting off lunar craters, which warmed parts of the lander not in direct sunlight. This data, likened to a snowboarder forgetting sunscreen under their chin, will inform thermal modeling for Firefly's upcoming Blue Ghost 2 and 3 missions, as well as other CLPS and Artemis programs. Blue Ghost Mission 1's success underscores the viability of NASA's CLPS initiative, which aims to foster a commercial lunar economy by contracting private companies for cost-effective payload delivery. With a $101.5 million contract, Firefly demonstrated that commercial missions can achieve high reliability at a fraction of the cost of traditional NASA-led ventures. The mission's success contrasts with earlier commercial attempts, such as Astrobotic's failed landing in January 2024, highlighting Firefly's innovative approach and robust design. Firefly's achievement has broader implications for the global lunar race. As NASA plans crewed missions starting in 2027, and China aims for astronauts on the Moon by 2030, commercial players like Firefly are proving essential in reducing costs and accelerating exploration. Firefly's upcoming missions, including Blue Ghost 2 to the Moon's far side in 2026 and Blue Ghost 3 to the Gruithuisen domes in 2028, will further expand its role in cislunar exploration, potentially supporting sample return and surface mobility. A milestone for the lunar economy. Firefly Aerospace's Blue Ghost Mission 1 stands as a testament to the potential of commercial space exploration. By achieving the first fully successful commercial lunar landing, operating for an unprecedented duration, and delivering critical scientific data, the mission has set a new standard for private sector involvement in space. The collaboration with NASA, Rocket Lab's software support, and the integration of flight-proven technologies underscore the power of partnerships in advancing space exploration. As Firefly prepares for future missions, the legacy of Blue Ghost Mission 1 will inspire a new generation of explorers and innovators. From capturing the Moon's ethereal sunset to enabling groundbreaking experiments, Blue Ghost has not only touched the lunar surface but also ignited possibilities for humanity's future in space. As Jason Kim aptly stated, there's space for everyone in space, and Firefly's triumph proves that the lunar frontier is open for business.